Contribution of Srinivasa Ramanujan in the field of mathematics. Srinivasa Ramanujan was one of India's greatest mathematical genius. He made substantial contributions to the analytical theory of numbers and worked on elliptic functions, continued fractions, and innate series. His father worked in Kumbankonam as a clerk. When he was nearly 5 years old, he entered the primary school in Kumbankonam. In 1898, he entered town high school in Kumbankonam and showed himself an able all-round scholar. Ramanujan came across a mathematics book by G.S. Carr called Synthesis of Elementary Results in Pure Mathematics. This book, with its very concise style, allowed Ramanujan to teach himself mathematics. The book continued theorems, formulas, and short proofs. The book, published in 1856, was of course well out of the date by the time Ramanujan used it. Ramanujan, on the strength of his good schoolwork, was given a scholarship to Government College in Kumbankonam in 1904. The following year, his scholarship was not renewed because Ramanujan devoted more and more of his time to mathematics and neglected other subjects. He continued his mathematical work. In 1906, Ramanujan went to Madras, where he entered Panchayappa's College. His aim was to pass the first arts examination to admit to the University of Madras, but he passed in mathematics only. He married on 14th July 1909 a 9-year girl, Janaki Ammal. In 1911, he approached Ramchandra Rao, a founder member of the Indian Mathematical Society, for advice on a job. Ramanujan continued to develop his mathematical ideas and began to pose problems and solve problems in the Journal of the Indian Mathematical Society. He developed relations between elliptic modular equations in 1910. After publication of a Billian research paper on Bernoulli's number in 1911 in the Journal of the Indian Mathematical Society, he gained recognition for his work. On 16th March 1916, Ramanujan graduated from Cambridge with a Bachelor of Science by Research. Ramanujan's dissertation was on highly composite number and consisted of 7 of his papers published in England. Ramanujan was elected a Fellow of the Cambridge Philosophical Society, and then, 3 days later, the greatest honor that he would receive, his name appeared on the list for election as a Fellow of the Royal Society of London. He had been proposed by an impressive list of mathematicians, namely Hartley, McMahon, Grace, Larmor, Bromwich, Hobson, Baker Littlewood, Nicholson, Young, Whitaker, Porteous, and Whitehead. He was elected Fellow of the Royal Society on 2nd May 1918 and then on 10th October 1918 as a Fellow of Trinity College, Cambridge. The fellowship to run for 6 years. Ramanujan fell seriously ill in 1917 and got improvement a little by September. By the end of November 1980, Ramanujan's health had greatly improved. Ramanujan sailed to India on 27 February 1919, arriving on 13th March. However, his health was very poor, and despite medical treatment, he died there on 26th April 1920. His contributions to mathematics. In 1900, he began to work on his own on mathematics, summing, geometric and arithmetic series. He made sustained contributions to the analytical theory of numbers and worked on elliptic functions and infinite series. He was shown how to solve cubic equations in 1902, and he went on and find his own method to solve the quartic. By 1904, Ramanujan had begun to undertake deep research. He investigated the series and calculated Euler's constant to 15 decimal places. He began to study the Bernoulli's numbers, although this was entirely his own independent discovery. In 1904, he worked by hypergeometric series and investigated relations between integrals and series. He was to discover later that he had been studying elliptic functions. Continuing his mathematical work, Ramanujan studied continued functions, fractions, and divergent series in 1908. Ramanujan continued to develop his mathematical ideas and began to pose problems and solve problems in the Journal of the Indian Mathematical Society. He developed relations between elliptic modular equations in 1910. Ramanujan independently discovered results of Gauss, Kommel, and others on hypergeometric series. Ramanujan discovered a number of remarkable identities that imply the divisibility properties of the partition functions. He worked on divergent series. He seen 120 theorems on divergent series to hardly in 1913. Goldbach's conjunctive is one of the important illustrations of Ramanujan's contributions towards the proof of the conjecture. Ramanujan and his associated had shown that every large integer can be written as the sum of the most four premises. 2s is equal to 2 plus 5 plus 7 plus 11. He worked on the unsolved format theorems, which states that a prime number of the form 4m plus 1 is the sum of two squares. His most famous work was on the number p in bracket n of partitions of an integer n into summands. McMahon had produced tables of the values of p within the bracket n for small numbers n, and Ramanujan used this numerical data to conjecture some remarkable properties, some of which he proved using elliptic functions. He did great work on magic squares. His Mohita functions are used in preparing medicine for cancer. 1729 is the smallest number which can be expressed as the sum of two cubes in two different ways. So 1729 is equal to 1 cube plus 12 cube is equal to 9 cube plus 10 cube. 1729 is called as Ramanujan number. Ramanujan developed a formula for the portion of any number which can be made to yield the required result by a series of successive approximation. A highly composite number is, in sense, very poor opposite of a prime number. A prime number has only two divisors, itself and unity cones. On Ramanujan's work of highly composite number, Hardy writes, the elementary analysis of highly composite number is most remarkable and shows very clearly Ramanujan's extraordinary mastery over the algebras of inequalities. In this way, one can judge the merit and competency of Ramanujan as a first-rate mathematician. Indian government announced the birthday of Ramanujan is celebrated as National Mathematics Day. The Indian postal authorities issued a stamp to celebrate the 75th anniversary of Ramanujan's birth.